right, here we are again. So it looks like everyone's more or less here. All right, so here's what we still have to do. We didn't quite finish the chapter 6 problem set, although we were very close. Hold on a second. Oh, here we go. Yes. So we'll do that first. And then I have an interesting little video for you to look at today. And then we're going to work on sample midterm. In my other class, we almost finished it, not quite. We're very close to the end. Probably the same thing will happen here. But I think we'll be able to finish enough that we can just, I can just post the midterm today, as soon as, not necessarily as soon as we're done here, soon afterwards, because I have a lot of classes today. But just want to mention a few things. First of all, hold on one second while I get myself organized here. All right, so as far as the midterm is concerned, as you know, it's based entirely on chapters 5 and 6. It's very similar to the sample midterm. Now, I'm going to post it sometime today. And so I just want to mention a few things. First of all, remember, this was written for a time when we're actually in the classroom. So the midterm was meant to take an hour and a half to finish. So what I'm going to do here is have you, you should hand it back in by Monday, the 15th at midnight. Now that's plenty of time. You'll have no problem finishing it. But by giving you a whole week, you will have plenty of time to ask questions in person, and during the classroom itself, or by email. That way. All right, so you got a week. Now here, what you should do is try, it's not the end of the world if this doesn't happen, to do the following. Send it, well, first of all, I'm assuming that you're going to write everything out by hand and then take pictures of it with your phone camera. Or if you have a scanner, you can do that too. Okay, you can scan it back to me, or you can just take pictures, but send it to my Purchase account, only because I have a lot less emails in my Purchase account than my regular email account. And if they're in that Purchase account, it's just easier to find them. It's just that simple. If you send them to my other account, Dr. AA, it's fine. I'll find it, but it's just easier if they're all together in one place. Try to save the files with your name. Okay, so that's just to make sure that I know who each one belongs to. So in other words, instead of something like that, it would be very helpful if it's instead John Smith, page 1.jpg would be infinitely more helpful. It just reduces the risk that I can't figure out who this thing belongs to, because unless your name is on every single page, it's possible for them to get separated. So just try to the extent that's possible. And if you forget it, it's okay, because I'll have your original email. Yeah, go ahead, Noah.
The way if I'm sending it from my phone, I can't change the titles of the photographs. So I'm just gonna write my name on every page.
No, then yes. Ideally, then if you're handwriting or typing, whatever. Yes, in that case, just to be on the safe side, and it helps me enormously if you put your name on every page. And again, it's just a precaution. I've never actually lost anyone's work, but it just saves me time trying to organize them and get them all together. So yeah, go ahead and try that. I'm glad you brought that up, because I didn't realize that with the phone you can't change the name. That seems a little odd, but all right. So if that's the case, yeah, try to put it in. And of course, I guess it goes without saying that you'll try to make your handwriting as neat as possible, because the harder it is for me to read your work, the less likely I am to, or the more likely I am to not give you the points that you deserve. And also, when you take the pictures, try to look at them first before you send them to me. Let's say you inadvertently your hands were shaking or something when you took the picture and it's very hard to read it. That's going to make it tough for me. So if you can't read what you've done with your picture, I'm not going to be able to read it either. So just try to make sure that the quality is good when you send it back. I find that this is especially important with pencil. If you're writing with pencil, try to make it as dark as you can, because there's something about pencil that it doesn't always photograph well. I don't know what the issue is. I'm not a photographer, but so if you're using pencil, just go out of your way to make sure that the writing is as dark as you can get it. And again, as usual, just be careful with the photographs because, like I said, it's important that I have to be able to read the thing before I correct it. All right. And naturally enough, organization, it's like, if I can see what you're doing, to the extent that's possible, show at least some of your work so that I can give you partial credits. All these little things will help make this a better experience for everyone. But in the past, it hasn't been a big problem, but occasionally I get a few that are it's hard to read, it's hard to follow them, and that only makes it harder for me to give them a proper grade. So anyway, so you shouldn't have any trouble finishing it up. It's pretty much exactly the same as the sample midterm. So if just do your best, and I don't think there'll be any problems. All right. So having said all that, why don't we now go ahead and finish up the chapters and problems. I didn't quite finish. Still had a few to go. So let me go get that open real fast. No, it's one. No, that's it. You got one shot at it. All right. If you goof it up, the best I can do realistically is maybe shuffle the weights around a little bit to help you out, like by giving you more points or weight towards one of the better exams. But no, I think under the circumstances, once is enough. It would be different if this was some kind of online system where they could shuffle up the questions and you could do it over and over again. We don't seem to have access to that kind of technology right now. So I think this is probably the better approach. Just do your best. All right. So, and like I said, to the extent that you've put down the steps that you followed, I can give you partial credits if something goes wrong. All right. I mean, assuming you did it correctly. You know how it is. Like sometimes you'll have a very complicated problem and somewhere along the way you miss a negative, and before you know it, the whole thing is goofed up. But if I can see what happened, I can give you a large percentage of the points. Okay. So don't be nervous. All right. It's just exactly what we've been doing all along. All right. So with all that being said, yes.
Professor?
Yes, go ahead.
For the writing, did you leave enough space to do the work, or should we do it on a separate page?
I would recommend, well, you know what you can do? It'll be a Word document. So what you can actually do is, if you want to, you can go in there and add all the space you need.
Yes. Okay. Thank you.
Yeah, as opposed to having to start all over again. Either way is fine, but since it'll be a Word doc, you can manually expand the space to as much as you need. All right, so I think we're ready now to get back to the chapter 6 problems that were not quite done. There's just a few at the end, so let's wrap this up today. And then we can dive right into the sample midterm, but only after watching a cool video first. Okay, hold on one second. Today's the 8th. Very good. All right, so we got pretty far into this. I think where we left off was some of the later factoring problems, specifically the ones where we have to rearrange the results algebraically. So why don't we start again here? Let's start with 23. How about that? So the key here is that this one is not written in the proper form, by which I mean ax squared plus bx plus c equals 0. So what do we do about it? Well, just a little algebra. We'll put it right back in the correct position, which means just subtract, in this case, the 51 from both sides. And so now we can go ahead and factor it properly. And now remember the way this works. You're looking for a pair of numbers with the following properties. Okay, let's get some of these turned off. All right. So we need a pair of numbers, a pair of integers, I should say, whose product is -51, but whose sum is -14. So let's run through some of the possibilities. 1 and -51 will give us a product of -51, as will -1 and 51. We also have 3 and -17. And we have -3 and +17. Now, I think that's it, but we've already got the ones that we need. How can you tell? Because we're looking for a pair whose product is -51, but whose sum is -14. And that's it right here. So this means that our factors are here. We can set these equal to 0, and then we can solve for them separately. In other words, in order to solve for this equation, we can say that x plus 3 equals 0 and x minus 17 equals 0. In other words, x equals -3, x equals 17. Those are my solutions. Now, we can double check this in two different ways. We can make sure we got the right factors by using FOIL. If you apply FOIL to these two factors, you will in fact come back with x squared minus 14x minus 51. But right now, why don't we just instead double check the solutions to make sure they worked out correctly. And you don't have to do this every time. In fact, double checking is never mandatory. It's just maybe a good idea, okay? Just to make sure something didn't go wrong. So we're gonna double check first with x equals -3. So what I'm going to do is literally just plug it in and see what happens. Oh boy. All right. So we want to make sure that this is actually correct. So we have 9. Now here we have plus 42, 51 minus 51, and yes, indeed. So basically, we just demonstrated that plugging in -3 gives us a value of 0 for the function, which is the same thing as saying that this is a solution of the equation. All right, now let's double check the other solution we came up with, which is 17, and let's see what happens. So 17 squared comes first. Okay, then we'll have minus 14 times 17. And then we'll have minus 51. Let's see if that equals 0. So 17 squared is 289. 14 times 17 is 238. And then 289 minus 231 is positive 51. Oh yeah, there you go. And so we're good. That means we must have done this correctly, because you can see that they do in fact provide us with the correct solutions. Now, by the way, what's nice about this is that if this is the case, then we must have factored them correctly too. So we don't really need to double check twice. In other words, we could have double checked this with FOIL, but the fact that this part works means that we must have factored the equation correctly. So only one double check is really necessary here if you want to do that. Now here's another one that is slightly out of the normal form. So we'll rewrite this one very simply by subtracting 20 from both sides, and we'll have our quadratic equation in the correct form. And now it's time to factor it, okay? So again, we need two numbers, two integers whose product is -20, but whose sum is -1. So what could they be? All right, let's try a few. And when we find the ones that we need, we can stop doing this. We don't have to write out every single pair of factors that gives us negative 20, but just to make sure, you might want to run through them all. And when we're done, you can see this is the only pair that works because the product is negative 20, but the sum is negative 1. So it must be the case that x plus 4 times x minus 5 equals 0. And that in turn means that x plus 4 equals 0 and x minus 5 equals 0. And therefore, we conclude from all this that the solutions are x equals negative 4 and x equals 5. All right, so we don't need to double check every single one of these. I just wanted you to see it once to make sure you can see how it's done. But if you did plug these in, you would in fact get the right solution in both cases. All right. All right, what's next? How about this one? So again, we have to make a slight adjustment. We're going to rearrange this algebraically to make sure it's in the correct format. So again, it's very simple, simple matter of subtracting that 81 from both sides. And now we need to find some factors where the product is negative 81 and the sum is positive 24. All right, let's try some. 3 is, oh, here we go. 3, oh, wait a minute, something went wrong here. Sorry, no, my mistake. There has to be a negative. Let's try that again. We can either have 1 comma negative 81 or negative 1 positive 81 because the product has to be negative. I was looking at the wrong thing, that's why. All right, good. Now, let's try 3 and negative 27. And negative 3 and positive 27. Now, we don't actually need to go on any further, but I just want to note that you also have these two possibilities. But we know that we found our answer because these add up to 24. Okay. So we're done, and we've got it. We've got our factors. X minus 3 times x plus 27 also equals 0, which implies that x minus 3 equals 0 and x plus 27 equals 0, or x equals 3 and x equals negative 27. All right, just leave that there for a second so you can catch up. Sees everyone here? Pretty much. Good, good, good. All right, and then there's one more, and then we'll be done with this one. Well, actually, no, then we still have a bunch of quadratic formulas to do. Woo-hoo. That should be fun. All right, and so they would be, let's try. First of all, it has to be rewritten a little bit. So what I want to do is subtract 64 from both sides, and I'm all set. And once again, I need a couple of integers whose product is negative 64, but whose sum is negative 12. All right, let's try a few. How about 2 and 32? 4 and 16. And we also have 8. Oops, negative 8 and 8, that's right. And guess what? We have a winner because we need a sum of negative 12, which is right here. All right, so that means that x plus 4 times x minus 16 equals 0. And that in turn means that x plus 4 equals 0 and x minus 16 equals 0, so that x equals negative 4 and x equals 16. Beautiful. Okay, so that was the last of those. Now we've got the next batch of questions are all asking us to solve the equation, but this time with the quadratic formula. Now, these are all, typically most of these are a little bit messier than what we've been dealing with. The thing about the quadratic formula is that it always works. The factoring can be a bit awkward under some conditions, like especially if the coefficient of x squared is not 1. We can run into some very messy situations. So the quadratic formula is always going to work, but it's good to be able to do both. So let's take a look at some of these. Now, right off the bat, remember the standard form for a quadratic equation is that ax squared plus bx plus c equals 0. Okay, so that means in this example, a is 3, b is 1. There's an implied 1 coefficient in front of x, and c is negative 1. Okay, so with that information, we have everything we need to know to solve this problem by using our friend, the quadratic formula. All right, so let's start doing some plugging in. Minus 1 plus and minus 1 squared minus 4, 3 minus 1. All right, so this becomes, now here you've got 1 plus 12 under the square root sign. And that means we're heading into trouble, as you can see, because 13 is a prime number. So you know what? We're done. We can't really simplify this any further. So you can leave it like this, or else if you want to take it one step further, you can rewrite it as minus 1 minus radical 13 over 6, comma, minus 1 plus radical 13 over 6. They both mean the same thing. When you can't consolidate them any further, you could just leave it like this first expression or the second. They're both fine. Okay, so all right, so hopefully everyone got that one. All right, let's see what's next. And again, you can certainly feel free to double check these by plugging them into that equation, but they're kind of messy, so maybe not. But it's okay if you want to do that, that's fine. All right. All right, now what's next? Now here we go. Here's one that's not written in the proper form. We have to do something about that. Otherwise, we're going to get the wrong letter. We're going to certainly get the wrong signs, that's for sure. So let's rewrite this as negative minus 2 equals 0. So now we can see that A is 4, C is negative 7. B is negative. What am I saying? B is negative 7. And C is negative 2. All right, so we're good. So the two x's that we're looking for, the two solutions, are, based on our quadratic formula, Okay, let's try this. So we have minus 7. Minus 7 squared minus 4, 4 minus 2 all over 2 times 4, 7 plus and minus 49 plus 32 all over 8. Okay. What else do we do? Now here we got lucky because if you notice, we have 81 under the square root sign, which of course is a perfect square. That's always very nice when that happens. So we have 7 plus or minus 9 over 8. Or we can write this as 2 terms, 7 minus 9 over 8, comma, 7 plus 9 over 8, which in turn means we have negative 2/8, 16/8, or we can simplify them a little further as minus a quarter, comma, 2. So there's 2 solutions, both of which will make this equation equal to 0. And so that's that. We're done. So we always end up with relatively nice results when we have a perfect square under that square root sign. If not, well, who knows what's going to happen. Okay. Now we're going to have another one, which is not quite in the right form, which means it has to be changed. And once we've done that, we can recognize that A equals 2, B is negative 5, C is negative 12. Okay, so with that in place, we can now go ahead and use our quadratic formula. Let's see if this one turns out nicely. It's hard to judge in advance. All right, let's see what we've got. Okay, so we've got minus a minus 5, plus and minus, minus 5 squared, minus 4, 2, minus 12, all over 2 times 2. All right, so we'll have 5 plus and minus 25. Now here we have 2 negatives. This is actually plus 96. And then we divide that by 4. And then we have 5 plus and minus 121 over 4. Now, of course, you recognize 121 is a perfect square. 11 squared is 121. So we got lucky again, didn't we? Yes. So we'll have 5 minus 11 over 4, 5 plus 11 over 4, minus 6 over 4, and 16 over 4. And then finally, we'll reduce that to minus 3/2 and 4. And that's it. We're done. All right, so I'll give you a minute to catch up. All right, let's see what's next. All right, now this one is already in the right form, which is kind of nice. And so that tells me that A equals 1, B equals 5, and C equals negative 12. All right, so here we go. Okay. So we have 5 squared minus 4 times 1 times minus 12 over 2 times 1. Okay. All right, here we go. Minus 5. So under the square root sign, we have 25 plus 48 over 2. Now, this one is not going to work out so nicely because, as you can see, we end up with the square root of 73, which is actually a prime number. So we're done here. We can't really take it any further except to possibly write it out like this. Okay, so that one's done. Sadly enough, we can't reduce it any further. All right, now this next one is already written in the correct form, so we can just go ahead and note that A equals 3, B is 5, and C is 1. Okay, so let's try the quadratic formula again. Oh, sorry. Minus B plus and minus the square root of B squared all over 2A minus 5. And then we have 25, or 5 squared, minus 4, 3, 1. Oh, this one doesn't look good either. I'll tell you why, because look what happens under the square root sign. 25 minus 12, oh no. Look what's going to happen. We've got minus 5 plus and minus radical 13 over 6. And that's it. We're done with it. Obviously, 13 is a prime number. And so if you want, you can write it out in the full form, but that's not absolutely necessary. Oh, sorry. Whoops. What am I doing? It's negative 5. It's equivalent to negative 5 minus radical 13 over 6, comma, minus 5 plus radical 13 over 6. But either definition is fine. Either way of writing it is fine. All right. Well, again, we can't go any further because 13 is a prime number. Sadly enough, I know you want to continue to simplify it, but not this time. Okay. Oh. It is discouraging, isn't it? Like, that's it. We can't clean it up anymore. No, no, not at all. No, absolutely not.
Oh, that, and I was like, oh, well,
Yeah,
that's weird.
it is. But you know what? Sometimes the answers are very bizarre. And so, no, you did nothing wrong. This is exactly what you were supposed to get. So, yeah, no, you're right. Sometimes it can be really scary looking, but that it happens sometimes. They can't all be nice, can they? No. But anyway, but some of them are. I mean, a lot of them did turn out to have, at least not prime numbers. Now, this one, we have to rearrange it slightly again. By subtracting the 3 from both sides. So now we can see that A is 5, B is 2, and C is -3. Let's plug that into our favorite formula in the world, the quadratic formula. All right, let's do it. So we'll have minus 2 squared minus 4 times 5 times -3 over 2 times 5. Okay, so what does that give us? 4. Now this one is actually plus 60. Okay, with 2 negatives, this becomes positive. And that's actually good news because that means we have ourselves a perfect square. Cause for celebration. So we actually have here -2 plus and minus 8 over 10, which we can rewrite as -2 minus 8 over 10, comma, -2 plus 8 over 10. So then, of course, that gives us -10 over 10, comma, 6 over 10. And then we can simplify these as -1 and 3/5. And that's much nicer, isn't it? Yes, it is. All right, so. All right, let's see what's next. All right, now this one is already in the correct form. So note that A equals 1. There's an implied 1 in front of that x squared. B is -8, and C is -9. All right, beautiful. All right, so let's try this. All right, -8. -8 squared. -4, 1, -9. 2 times 1. 8 plus and minus 64 plus 36. Now this one is looking very promising because, oh, look at that. We have 100, the ultimate perfect square. All right, so this one will reduce very nicely to 8 minus 10 over 2, comma, 8 plus 10 over 2, which is -2 halves, 18 halves, And then finally, when we're done, we just have -1 and 9. In fact, this one is really straightforward. You can see if you look at it very carefully, we could have factored this one. It's really simple. But what the heck? Let's just keep doing the quadratic formula. But yeah, if you factor this one, you'd see that it would have worked out the same way. All right, very good. Now, hopefully there's some more nice ones coming. I think there's only 2 more. Let's see what's going on here. Oh, there's only 1 more. Oh, what a bummer. All right, 1 more. This one, it has to be rearranged slightly. So we've got -35 equals 0. And that means that A equals 6, B equals 1. There's an implied 1 coefficient for X, and C is -35. Okay. All right, let's check this out. Okay, minus B plus or minus B squared minus 4AC over 2A equals -1. 1 squared minus 4, 6. Ooh, this one looks pretty scary. We'll find out if it is or it isn't. So we have 1 now. -4 times 6 times -35 works out to be 840. Now, you'd never guess it, but 841 turns out to be a perfect square. It sure does. You would never have thought so. Now, if you're not sure, you can just go to your calculator and take the square root of 841, and you might be surprised to discover that it's 29. How do you like that? Who knew? That was a very non-obvious perfect square. Let's put it that way. 29, that's right. So anyway, so that means we have -1, minus 29, comma, -1 plus 29 over 12, minus 30 over 12, comma, 28 over 12. And then they can both be reduced quite a bit. As a matter of fact, this first one is -5 halves, comma, because you can divide out 6 from both the numerator and the denominator. In the second case, we can divide out 4 from the numerator and the denominator, and we'll end up with 7/3. Although, I mean, if you wrote it like this in the test, that would be okay. But, with mathematics, we always want everything as simple as we can get it. Always. Okay, mathematicians are very tidy people. All right, so all of that is done. So that was the end of the chapter 6 problem set. It's completely finished. I'll post the rest of these solutions later on today. And but in the meantime, we do have an interesting video. Now, the video is basically tracing back to the beginning in the early days of when this type of approach would have been important in helping solve very important problems. Now, there's a little bit of a history lesson in here, but they're also going to explain very well what a quadratic equation actually is and what we're trying to do when we solve it. It's a little on the silly side, but it's fun. You'll like it, I think. All right, so let's take a look at this, and then we'll get back to the sample midterm. All right, so just be aware it's a little on the silly side, but I think you'll like it anyway. Let's see, hold on one second. It should be on Moodle. It's under right here. It's called quadratic equations, interestingly enough. All right, so let me get that sent out to you. And let's begin. All right, well, that was interesting. Nice little break from all these reviewing, huh? All right, so now we have to get back to serious business. It's time to do the sample midterm, which we'll do right now. And in my other class, like I said, we didn't completely finish it, but we were very, very close. So we'll do as much as we can, and we'll wrap it up on Thursday. So let's just get that going. Now, of course, when you see it, you'll realize that it's all exactly what we've been doing all along, as will be the actual test. All right, hold on one second while I get my stuff here. Let's see. What are the factors of 60? Now, 60 actually has quite a few factors, surprisingly many factors. So what are they? Well, remember, all we have to do here is multiply out all the natural numbers whose product is equal to 60. And it's quite a long list, as a matter of fact. For example, we have oh, here we go. Oh my God, somebody said, yes, that's exactly right. And so the way we get that is to write out, or one way to do this is to write them out in pairs. And the list just goes on and on and on. And then all of a sudden you realize, well, we're done. There's no more. And then you can write them out in numerical order: 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Yes. Okay. So that answer is absolutely correct. And so those are our factors. Very nice. Okay, what's next? The factors of a prime number. It doesn't matter which one it is. The factors are 1 and the number itself. That's it. That's what it means to be prime. There's only two factors, 1 and the actual number itself. All right, very good. Common multiples, these are pretty straightforward. What are you doing with multiples? All you're really doing is multiplying each number by all of the natural numbers. And in this case, we're going to keep going until we find the ones that we're looking for. Let's try a few more. So that's the 3. And for 7, we'll start with 7, 14, 21, 20. Oh, wait a minute. We can stop right now because we notice that we found what we were looking for, the smallest or least common multiple of both numbers is in fact 21. Okay, so there is no other number which is a multiple of both 3 and 7 and is also smaller than 21. So the least common multiple of 3 and 7 is 21. All right. Now, I know that there are other techniques that are available out there, but I think this one is the most straightforward. But you can use, if you learned a different technique in your school, that's fine. You can use that too. All right. Now, this next one is kind of fun because this one is the one where we get to draw that binomial tree where we're looking not for factors, we're looking for prime factors, which means we're excluding 1. All right, so let's start with 24. So if you remember, the way these trees work is we're breaking down a number into its factors, and we will stop when all the numbers are primes. Okay, so for 24, the prime factors, or we should say the prime factorization is 2 times 2 times 2 times 3. And for 36, let's see, we'll do 2, 18, 2, 9, 3, 3. So here the prime factorization is 2 times 2 times 3 times 3. Now, what we're looking for is what they have in common. Now, they both have 2 2s, and they both have a 3. All right. Oh, it doesn't matter which 3 I circle. Let me just do it this way. Okay, so the greatest common factor is the product of the common prime factors of the two numbers, which is, and then so you just multiply them out, 2 times 2 times 3, which is 12. Okay. Now you can see that 12 evenly divides into both of them, and there's no larger number for which this is true. All right, so 12 is the final answer here. All right, so it's all coming back in a flood, isn't it? It's already been like 5 or 6 weeks since we did this stuff. It's hard to believe. You know, for a while, it always seems like we just really got started. And now we're looking at, we're getting towards the middle of the semester. In fact, man, we're really zooming along here. If it was a normal semester, we'd be having spring break in a few weeks. But no, we're not having that this year. There's a few days off, I believe, but not any that affect this class as far as I know. Yeah, that's right. So we're not going to have any days off, but that's okay. We'll get more math done that way. So maybe next year, maybe in the fall, you'll be able to have, well, no, the fall wouldn't have one anyway, but next spring, you should have a spring break if things carry on the way they are. Anyway, a composite number is one which is not prime. So the best way to explain that is to say that a composite number has at least one factor other than 1 and the number itself. Okay. That's all it needs. As long as there's at least one more factor, it's no longer prime. It is now considered to be a composite. So all of the natural numbers are either prime or a composite. Now, the smallest prime number greater than 30, what you could do, you can just start writing them all out if you want to. But it's not absolutely necessary because all you really have to do is start with 31. Why? Because it says greater than 30. And so you start by testing 31 and you discover that, hey, wait a minute, 31 is prime. So already we're done. Okay, so the smallest prime number greater than 30 is 31. So we got lucky with that one. It could have taken a while. It can be very tricky to make sure that a number is indeed prime. You would have to go through the list of factors like we did up here. And eventually you'd realize that there just aren't any besides 1 in that number. Okay, like with the 31, you start with 2 and 3 and 4 and all the rest. And you discover pretty quickly that they are not factors. And you'd realize pretty quickly that it is a prime number. All right, here we go. These are some of our favorites. Simplifying radicals. Okay, these are always kind of fun. I guess by math standards, they're fun. Now, with these types of situations, like here, for example, what we ideally would like to do is find 2 factors for 48, of which at least one of them is, if possible, a perfect square. Now, there's more than one way of doing it. Here, we've got 4 times 12, or we can have 16 times 3. Both of those would work, and they'd eventually give us the right answer. But usually, if you've got more than one perfect square in there, you're probably better off picking the largest one first. That will reduce the number of steps. So 4 would have been fine, but you would have had extra steps involved to simplify the 12. Here, we only have 2 steps really, or 2 or 3. But no matter how you approach this, you're always going to wind up with 4 radical 3. Okay, nice result. Well, fairly nice result. All right, now how about this one? Well, it turns out that if you look at it very carefully, you'll discover there is a prime number, I'm sorry, a perfect square hiding in there. 144 times 2. Look at that. So if you didn't notice that right away, again, you could try other possibilities. For example, this one should be divisible by 4. And it is, yes. But if you did start with 4, you would still have to carry on and do some more simplification. Here, the largest perfect square that is a factor of this 288 is in fact 144. And that takes you directly to the solution. If you tried a different approach and you got the same answer, that's fine. Very nice. All right, now let's try this one. Now you remember that we're not allowed to combine radicals if they do not have the same number under the square root sign, but this one can still be simplified a little because 4 is of course a perfect square. So you have 3 radical 2 plus 8, or now mathematicians in a case like this would prefer that you write the radical second. Not that it really matters, but if you're a mathematician, this is what you would prefer to see. The natural number plus some function of a square root, as opposed to what we have here. All right, either way, you've got the same numbers. Very good. All right, now here, we're multiplying, so we're going to end up with 2 times 5 times the square root of 7 times 13, which is 10 radical 91. And it turns out that 91 is prime, so we're done. In fact, you know what? It just suddenly dawned on me. Why don't we try this just for the fun of it? Because, you know, you never know. If there's technology available. No, what are they talking about? No, what are they saying here? I don't think so. Wait a minute. Is that right? 91 divided by 7? Oh my God. Well, look what we just discovered. My fault. This is not a prime number. That's what I get. No, you're right. They're right. But you know what? It doesn't do any good. I'll tell you why. Because the factors are 7 and 13. That doesn't help us simplify. It doesn't have to be a prime number for us to stop right here. In other words, the fact that it's not prime doesn't mean that it can be simplified any further. I mean, what good does it do us to write this? The answer is it doesn't. So we may as well just leave it like this. Okay, so no, so my mistake. 91 is not prime, but we cannot simplify it any further. And that's all that matters in this context. All right, now this last one. Ooh, what can we do with this one? We got a couple of options. And again, you might get this through a different path, but in the numerator, you'll notice that we had this one earlier. This can be rewritten as radical 16 times 3. So you got 4 radical 3 over 2 radical 3. And of course, the radical 3's cancel each other out and you're just left with 2. So now that's a nice result. Look how much simpler that is than this. A lot simpler. So that's a very satisfying result. Okay, I think you'll agree with that. Now, ooh, exponents. We like exponents. We like them a lot. So for example, here, if you recall, x to the 0 just equals 1, any x. So that means this is true here too. Now, for these, you can get your calculator to help you out. In many of these cases, that is. So if you weren't sure, you just go to your calculator and type 3 raised to the 0 power, and it'll come up with a 1. And you're perfectly allowed to do that. Now, how about this one? Now, we have to be careful with negative exponents because negative doesn't mean there's a negative number. It means that this is a ratio. Okay, 1 over 16. Now, if you did this with your calculator, you would have gotten the decimal equivalent of this, which is 0.0625, and that's perfectly acceptable too. It doesn't have to be a fraction. Either one is fine. Now, in this case, we're using the so-called power rule. You're actually going to wind up with 3 raised not to the 2 plus 3 power, but 2 times 3. So 3 to the 6 turns out to be 729. All right, now, but on the other hand, look at this one. It looks very similar, but it's not, because this time we're using the product rule, which means we are adding the exponents. Oops, sorry, hold on. 3 to the 5th, which is, as you can see, is not 729, it's 243. Beautiful. Now, this one is the quotient rule. Remember, what you're doing here is you're taking the difference in these exponents. In other words, I'm subtracting what's in the denominator. And that in turn can be written as 1 over 4 to the 5th, or 1 over 1024. Now, if you want to, you can write that as a decimal. And that wouldn't give it, it's like 0.009, but I think it's, you might as well just leave it like that.
I have a question.
Yes, go ahead.
When are you supposed to write like a 1 over the rest of it?
Whenever there's a negative exponent.
Got you. Okay.
That's every time. So like here, that means this is the same as 1 over 4 to the positive 5th.
Got you. Okay.
All right. Anyway, now these next two, you could actually solve these next 3. You could go use your calculator if you want to. In fact, like this one, for example, you would put 8x, y. You have to be careful with this one because you need parentheses to get to this one. And you'll end up with a 2. And you can tell this must be the right answer because if you write it in reverse, 2 cubed is 8. And also keep in mind, this is just shorthand notation for the cube root of 8. Actually, now that I think about it, your calculator has a cube root function. So you could just type, you just go double check mine. I don't think you'll need an equal sign because that's a built-in function. And I guess they put it in there as part of that function. If you type 8 and hit the cube root button, it does work automatically. Okay, 8, and you'll just end up with your 2. Now, how about this one? Now there's a negative, so you can start by rewriting this as 1 over 27 to the 1/3. And now you're taking the cube root of 27, which itself can be obtained in the same way we had up here. You can use your cube root button, but what you could also do is put something like this, 27 x to the y. Now with this calculator, there is a plus minus button, which will turn this into a negative. And that will give you, now the only negative thing about this is that it won't give you 1/3. It will give you the decimal equivalent of that, but you'll recognize it right away as 1/3. So 27 x to the y power, parentheses, 1 divided by 3, close parentheses, negative, equals, and it will in fact give you, as I predicted, 0.33333. Another possibility is to do this. If you don't want to deal with the negatives, I don't know if this is too complicated, but if you did something like this, if you raise this to the 1/3 power, what you could do is then follow it up with this 1 over x button, because you know that, it was negative 1/3. 27 x to the y, 1 divided by 3. Okay, enter. 1 to the x is wherever on the left, and it will give you the correct answer. That's up to you. There's a lot of possibilities here. Beautiful. And then finally, we have one more, maybe one of the more challenging ones, which is 64 to the 2/3 power. Ooh, look at that one. Now, what you could do is first just recognize what this actually means. And now, based on the power rule, you can see that this must equal 64 to the 2/3, because you would just multiply 2 times 1/3 to get to this result here. But the nice thing about this setup is that you can take the cube root of 64 first, which turns out to be 4. And look how easy that turned out to be. The other option is to just go back to the calculator and say, all right, 64 x to the y, open parentheses, 2 divided by 3. And you should end up with exactly the same thing. All right, let's double check that. Hopefully you've got it. Oh, yes, I know you have it right in front of you, but let's make sure it's on the calculator function. Raise it to the open parentheses, 2 divided by 3 power, equals 16. All right. Oh, that was it for those. Okay. Scientific notation. All right. Now remember, the way this works is that we have to make sure this number has only a single digit before the decimal point. And then we need to find the exponent of 10 that makes this work. Now, one way you can do this, an informal way, is to say, well, you know what, how many places do I have to shift this decimal to come up with this number? So if you do that, you'll get 1, 2, 3, 4. So 4 places. The other way to look at it is to say, well, 10 to the 4th is 10,000. If I multiply this by 10,000, I'm going to get this number, 12,452.17. And the nice thing about this is you can double check your results on the calculator by typing 1.245217 EE4. Remember that EE? That just means raise some, 10 to some power. And so if you do that, 1.245217 EE4, you don't even need, oh, you do need the equal sign, but it will give you back the original value. And that's how you know you did it correctly. All right, now we're going to go the opposite direction with the next one because it's a tiny little number. So we know already that it has to look something like this. 4.098 times 10, and it'll be some negative power. The question is what negative power? Now here we're shifting in the other direction. 1, 2, 3, 4. It's just a coincidence that it's the same. -4. I shifted over 4 places, so this is my answer. And again, you can double check very easily by saying, all right, 4.098 EE4. Now you have to watch it here by putting in that negative sign and then equals, and you should get the original value. Okay, so 4.098 EE4 negative equals, and there you go. 4098. Excellent. All right, now for the arithmetic sequence, all you have to remember, you don't have to define what a sequence means. Just say that this is a sequence in which there is a common difference between the terms. Okay, the key word to all of that is common difference. That's really the bottom line. And then for the geometric, we just say this is a sequence in which there is a common ratio between the terms. That's the key difference. One has a common ratio, one has a common difference. All right, now we get to do some formulas. Woohoo! All right. So for F, we're looking for the sum of the first 5 terms. So first of all, just make a note here that this is an arithmetic. Oh, wait, sorry, I got the wrong one. E is next. So this is an arithmetic sequence with a common difference of 2. All right, so that's the key to the whole thing. A1, the first term is clearly 2, and D is 2. All right, once you got that straight, the formulas are easy. Now, for the 10th term, if you just write them out, you will get the right answer. And I won't take points off for that because it just says, what's the 10th term? It doesn't say you must do it a particular way, but I would like you to be able to use this formula as well, which, as you recall, is that AN equals, okay, A1 plus n minus 1d. All right, so therefore, A10 equals 2 plus 10 minus 1 times 2, which is 2 plus 9 times 2. 2 plus 18 equals 20. And that's it. But you also, if you wanted to write them out, you can do a double check. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, just as we expected. Perfect. Now this one, they're interested in the sum. Okay, so this is an arithmetic sequence with a common difference of 4. Okay, great. Now, if what we're looking for is the sum. Now, in order to do this, you do need to have the fifth term, which you can see is clearly 17, but why don't we use our formula just to get some more practice? Okay, so A5 in this case would be 1, since the first term is 1, plus 5 minus 1, and the common difference is 4. To have 1 plus 4 times 4, which is 1 plus 16, equals 17. So now we're done because we're looking for the sum. So if you recall, and you'll have access to all of your notes and everything, so you don't have to memorize anything. But the sum in this case is written as Sn equals n A1 plus An over 2. So we're looking for the sum of the first 5 terms. The first term was 1, the fifth was 17. And that's 90 halves, which is 45. And of course, you can double check it. You can just add those up, and you'll see that you do in fact have 45. All right, now for these next two, you can see something's very different here. This is clearly not an arithmetic sequence. This is a geometric sequence with r equals common ratio, I should say, equals 4. Now you can multiply these out and find the 8th term yourself, but these numbers are going to start getting really, really big. So here you may want to just use the official formula, which is An equals A1 times r to the n minus 1 power. So therefore A8 would have to be 1, since that's the first term here, times 4 raised to the 8 minus 1 power, which is 4 to the 7th, and that is equal to 16,384. And then we've got this one, which is also clearly geometric. You can tell because it grows very, very quickly. And, it's another case where if you wanted to, you could start writing out the other terms, but there's no real need for it because the sum for the geometric sequence does not require us to know what that term actually is. It looks like this: A1, 1 minus r to the n, over 1 minus r, 2, 1 minus, oh, by the way, the common ratio here is 3. I forgot to mention it. Okay, in fact, let me just throw that in there real fast. All right, so now we just do some algebra. And we'll have, so 3 to the 6th is 729, as it turns out. One minus 3 is clearly minus 2. Okay, so you're going to have minus 1456 over, whoop. And so this reduces to 728. Okay. Now, unfortunately, it's already 12 o'clock. So what's left here is just a few. We've got FOIL, we got factors. Yeah, we got a little ways to go here, but we can finish these on Thursday. In the meantime, I'm going to put up, like I said, the midterm, and you can start working on it right away, or you can save it till Thursday, whatever you want to do. It won't be due until midnight next Monday anyway, and so you'll have plenty of time to work on it. And in the meantime, I guess we'll stop here, and we'll see you on Thursday, and we'll wrap this up. And then I guess we'll start something new. But in the meantime, you can feel free to start that midterm anytime you like. And, like I said, you'll have more than plenty of time to do it. So, and plus you'll still have plenty of time to ask questions, whether in the class or by email if you need to. All right. So unless there's any last minute questions, I guess I'll just see you all on Thursday.
Quick question.
Yes, go ahead.
So is this open notes? I mean, I know you said we had
Oh,
access to
yes,
the
open
notes.
everything. Yes,
All right,
open.
awesome. Okay.
So what you might want to do is get your notes together and organize them so you don't waste time flipping through a bunch of pages.
Right.
You know what I mean? You can write up your own formula sheet. You can do whatever you want. Whatever it takes to get your materials organized, that's probably what you should start working on. And not that there's a time limit, but still, test corrections, no. Whatever you hand me is your final result. In other words, there used to be a game show on called Who Wants to Be a Millionaire, and they give them a bunch of these multiple choice questions, and then they would the people would start mulling them over, and a lot of times they couldn't come to a decision. So in order to speed things along, they had to say, is that your final answer? Meaning, are you sure that's what you mean? And if they said yes, that's it. It was either yes or no, end of story. So whatever you hand me is what I'm going to correct. Okay. So anyway, so I guess I'll see you all then on Thursday. No phoning a friend. Oh, you have seen that show. No, none of that. This is meant to be your own work. Yeah, no. Because what if you know Albert Einstein or something? No. Okay. So, all right. So I'll see you all on Thursday.
Bye, thank you.
Thank you. See you Thursday.